company known as Pharmos, and it was produced for the treatment of neuroprotection in cases of traumatic brain injury. It performed very well in phase 1 studies, it performed well in phase 2 studies. They did a major worldwide phase 3 trial looking at whether patients who were brought into a hospital after sustaining severe head injury, whether the administration of dexanabinol would help protect their brain cells. It failed in the phase 3 trial. I have some theories as to why that might have been the case. I think in large part it had to do with the lag time between when the injury took place and when the administration of dexanabinol took place. In the case of the trial, there was an average gap of 6 hours, and I think at that point the brain damage was probably irreversible. I don't know that, I'm not a scientist, but I do want to point out that when we're talking about some of these findings in animals, we can't necessarily conclude that the same thing would happen in humans. This is a case where there were many people, a lot of time and money was spent, who were convinced this drug was going to work in humans, and in the phase 3 trial it didn't, despite the fact that in animals it very clearly has shown this neuroprotective effect. Something else I want to talk about, cannabinoids and glioma. You've probably heard that marijuana can lead to cancer. Well, these are very interesting studies that actually show that cannabinoids can work effectively as anti-cancer agents. Specifically in this case of glioma. Just a bit of background, glioma is an aggressive form of brain cancer that afflicts about 20,000 Americans annually. Glioma tumors are typically unresponsive to surgery and standard medical treatments. Left untreated, patients that develop this cancer generally will perish in 18 months' time. And I should also note that they respond typically not very well to conventional therapy, but they do seem to respond well to cannabinoids. Why do I say that? Well, in 2000, Nature Medicine reported the findings from a Spanish research team led by Manuel Guzman. He showed that if you injected THC actually into the tumor, then it induced considerable regression of malignant glioma in rats. They said THC administration eradicated brain tumors in 1/3 of rats treated and prolonged the survival of another third. They concluded these results may provide the basis for a new therapeutic approach to the treatment of malignant gliomas. One thing I do want to point out in this was a preliminary study. I think this was the first time they found this finding in animals. There had been some findings in culture, but they used very low doses of THC, and they also took rats that had a very short period of time to live. Yet, despite the fact that they did that, they were able to prolong the survival in actually a third of these rats. The researchers were actually shocked by this finding. And they commented that here again, were they who had taken rats that did have longer to live, or if they had administered a greater amount of THC, they probably would have had even better results, despite the fact that these results on their surface are pretty darn impressive. This was a research team from Italy. They actually looked at both in animals and in human cell lines what happens if you administer, once again, this non-psychoactive component of marijuana known as CBD in human glioma cells. What they found was the addition of CBD in the culture medium led to a dramatic drop in the viability of glioma cells in a concentration-dependent manner. That simply means, once again, the more they gave, the better effect it had. Scientists further demonstrated that the administration of CBD in mice significantly inhibited the growth of implanted human glioma cells. And it was doing this via a process known as apoptosis, which is another way of saying cell suicide. The cell actually turns on itself and kills itself. They concluded that CBD produces a significant anti-tumor activity both in animals and in culture, thus suggesting a possible application of CBD as an anti-cancer agent. Once again, we're back to Spain. You'll notice a trend here. Very few of these studies take place in the United States. Not coincidental, by the way, that is actually taking place. This is September 2004. This was a review also led by Manuel Guzman's team. Actually, I think this is a very important review for the findings that I've put there on the screen. As it notes, generally when we try to treat glioma, we don't do it very well. The patient still dies. During the last few years, several studies have shown that cannabinoids slow the growth of different types of tumors, including brain tumors in laboratory animals. This is very important, point 3. Cannabinoids they seem to go about killing these tumors two ways. One way is this idea of cell death that I mentioned earlier. The other way is that the cannabinoids seem to cut off the blood flow to the tumors, and without the blood going to the tumor withers and dies. So it's actually a two-pronged sort of strategy. For the tumors that are already there, administration of cannabinoids seem to trigger the tumor to actually kill itself. For the tumors that are just forming, it seems to cut off the blood flow so they do not come to fruition. Something else that's actually fairly remarkable, this is point 4, even the scientists noted this was remarkable. Cannabinoids kill glioma cells selectively and can protect non-transformed cells from death. What that means is that cannabinoids seem to discern between the healthy cells and the malignant cells. It leaves the healthy cells alone, it attacks the malignant cells and kills them. That's something standard chemotherapy doesn't do. That's why people get very sick when they're given chemotherapy, because chemotherapy isn't selective. It attacks the cancerous cells, it attacks the healthy cells, and people get very, very ill when that happens. So the idea of having an agent that can selectively go after tumor cells while leaving healthy cells alone, there again is fairly groundbreaking, and I'm somewhat offended by the fact that our government is not either encouraging this sort of research, funding this research, or even acknowledging it exists. The conclusion of this team from Spain was these and other findings reviewed here might set the basis for a potential use of cannabinoids in the management of gliomas. You'll notice that's a fairly common refrain. We do a study and then we determine that this is very hopeful and maybe someday down the road it will be the basis for new therapy. I've been hearing that for about 20 years. I'm starting to wonder when this new therapy will begin. They did try to follow up this study in humans in Spain. As far as I know, it's the first time that a study has been done on human subjects with brain cancer. It was done on 9 terminal patients. They were given about 3 months to live. And at that point, they were allowed to have cannabis. And what they discovered was in these 9 patients, they did have a reduction of brain tumor growth. All the patients did die, which was not unexpected because they did only have 3 months to live, but they did see a reduction in the actual tumor growth. I'll be interested to see if this study gets written up. The reason I know about it was because I had the fortune a couple weeks ago to travel to Santa Barbara to the Patients at a Time conference, which was an excellent conference for people who are interested in these and other sort of health-related medical issues. And they did bring in one of the researchers from Spain, and we talked quite a bit about this human study. And hopefully it'll be written up in a journal sometime soon so we can talk about it. Finally, on the subject of neuroprotection, and this, believe it or not, was a study that was actually done in the States. It was actually done at California Pacific Medical Center, which I believe is here in San Francisco. What they were looking at here was, once again, can this non-psychoactive cannabinoid CBD, how it interacts with human glioma cell lines. And once again, they discovered not only that, in this case CBD, but also THC led to a reduction of these particular cells, but they compared it to a synthetic, what's known as an agonist, a synthetic agent that mimics the effects of cannabinoids and binds to the same receptors. And what they said was that the same concentration of delta-9 THC that significantly inhibits the proliferation and increases death in human glioma cells had no significant impact on primary glial cultures. Evidence of selective efficacy with the synthetic agonist was also observed, but the selectivity was less profound. What that means in layman terms is that the natural cannabinoids were very selective. They went after the malignant cells, they avoided the healthy cells. When they gave the synthetic agent, it was also selective, but it was not as selective as the cannabinoids were. In short term, marijuana works better than the synthetic agent. I doubt anyone here would be surprised to hear that. Another topic I want to talk about briefly, this idea of cannabinoids